We're going to do a past paper, 2024 past paper. This should be 1120, yeah? So, Yusuf, to anybody who wants to review a first year um, university paper for mathematics. Okay, so it's a good foundation to start with, and we'll start with question one. So, express 2022.3 recurring minus 5.25 in the form of A over B, where A and B are integers and B is not equal to 0. Okay, so how do we handle that? Of course, that's coming from rational numbers, right? So 22.3 recurring. What does this number mean? So this is exactly what you'd see on a calculator where you've got threes just like that, not ending. So that's what recurring, or that's what the bar or the number represents. I believe we know that already. So if we were to write that in form of A over B, this one can easily be made in the form of A over B. So before we even subtract, I think let's convert this to a rational number. Okay, so I'll use this trick. So let our x be equal to that, right? What happens if we get to multiply both sides by, we only have one recurring number, so we can just multiply by a 10, so that we have 10x um, equivalent to 22. Now this 3 will move, so it would be 223. Remember, we're saying the number is 22.33 recurring, so if you multiply by a 10, you still have recurring 3's there, right? So it will still be 0.3. Okay, um, so this is still 3 recurring, by the way. So now we can try to subtract 10 minus the x, um, that would be 9x, and then we can equally subtract the right hand side, 223.3 recurring minus 22.3 recurring. The idea is we want the recurring parts to subtract, so then you remain with a 1, a 0, and a 2. So what is 201? So to find the fraction, it will be 201 divided by 9, right? 20 divided by 9, how many times? That's twice, because 9 times 2 is 18, so giving us a remainder of a 2. 9 into 21 is how many times? I don't think that's possible, so let's not divide by 9. Let's try a 3. 3 there is how many times? 6, giving us 6 times 3, that's 18, so remainder carry 2. And then 3 into 21 is 7, so we have 67. 9 divided by 3 itself is 3, so that is our fraction. Okay, so we've converted our 22.3 recurring to the form of a b 67 over 3. So if you have a calculator, actually you can try that. Punch 67 over 3. If you convert it to a decimal, it's going to give you 22 point recurring 3's. Okay, so there we have that. So we can now have 67 over 3 minus 5.25. Now we'd have to convert 5.25 as well, which I believe you're able to a fraction. So we just have to multiply, move the decimal how many times? Twice. 1, 2. So that means we have to multiply by 100. So I want to make sure we don't change the number, so whatever you multiply should also be divided. So you end up with 525 over 100. So after multiplying the top part, the decimal has moved twice, and then we are still dividing by the 100. Okay, so you can try to reduce this. I'm assuming calculators are not allowed, by the way, in this exam, so that's why I'm trying to do all these things manually. So 5 into 100 is 20 times. Then 5, I think you can divide by 25 instead. I can see this is gonna work. 25 into 100 is like 4 times. And then how many hundreds do we have in a 500? We've got 500s. So that means 5 times 4 is 20 plus the extra. So I'll do this 500s. So in each 100, the 25 is going there how many times? 4 times. So we can divide each 100 by 25 4 times. The hundreds are 5, so 5 times 4, that's 20, plus the extra 25, that's 21. So we have 21 over 4. So we have 67 divided by 3 minus 21 over 4. And then at this point you're able to subtract this. So common denominator is the 12. 3 divided into 12 is 4. So we have 4 multiplied by 6, 7 minus 4 into 12 is 3. So 3 times 21. Okay. So at this point now you're multiplying 6, 7 by 4. 4 times 7 is 28. 4 times 6 is 24 plus 2, 26. So 268. 21 by 3 is 63. So 63 minus 268. That's going to be 8 minus 3 is 5, 0, 205. So I have 205 over a 12. So we've actually now expressed the difference of that in the form of A over B, which is a fraction, right? So we've handled the first part with confidence. And so in summary, you can't subtract a recurring number with a non-recurring number. So first of all, we would want to convert the recurring number into a fraction itself, and then even the other decimal number into a fraction, and then you subtract the fractions. Subtracting fractions, applying fractions will give you a fraction, a rational number. So express the complex number negative 2 plus 4i over 1 plus 3i plus 2 minus I raised to the third power. So every time I'm actually teaching complex numbers, I always tell my students, just do me a favor and master one thing. I squared is equal to negative 1. That's enough. That's sufficient to help us simplify whatever we have to do. And then when it comes to addition and subtraction, go by the like terms. When it comes to division and multiplication, deal with a conjugate. Okay, so you understand what I'm talking about just in a second. In fact, multiplication deals more with this, and then yeah, you'll see. So we've got division there, so that's the first thing we have to handle here. Okay, so we have 1 plus 3i. So how do we handle that part? So we have negative 2 plus 4i over 1 plus 3i. For us to divide, we'd have to multiply by what we call the conjugate of the denominator. So the denominator is 1 plus 3i, the conjugate of that is 1 minus 3i. So we do the same to the numerator as well. Now if you're not new to complex numbers, you understand that each time you're multiplying a complex number by its conjugate, just multiply the like terms, because we understand the middle part will subtract. Let me show you what happens there. 1 times 1 is a 1, so we're using that one, and then multiply by the negative 3i. Now we can go to the second part. 3i multiplied by 1 is positive 3i. 3i times negative 3i is going to be a minus 9i squared. So you see that the middle part is actually cancelling out, right? So it's just as good as multiplying 1 times 1 and then 3i times negative 3i, which will just be 1 minus 9i squared. So that's what we do when you're multiplying the conjugate, the complex number. So in short, we just have 1 minus 9i squared for the denominator. For the numerator, we can multiply everything. Negative 2 multiplied by this part. So we're going to have negative 2 and then positive 6i. Negative 2 multiplied by negative 3 will give us a positive. And then 4i plus multiplied by the 1 will also be 4i. 4i times negative 3i, that's going to be a 12, a minus 12 actually, I squared. And then that will give us negative 2 plus 10i. Now I squared, we're saying I squared is equal to negative 1. So we're going to have, let's call this 10i minus 12. I squared is negative 1 over 1 minus 9. Now I squared is negative 1 again. So here we've got negative 2. Negative 12 multiplied by negative 1 is going to be positive 12. So we have negative 2 plus 12 plus 10i. So that gives us a 10 plus 10i, right? And then on the denominator part, negative 9 times negative 1 is a positive 9 plus a 1, 10. So we have 10 plus 10i over 10, right? You can divide by 10, each term 1, 1. So you just have 1 plus I. And then we have to add this part. So we can also try to simplify that part. I'm hoping it can also simplify. So 2 minus I, open brackets 2 minus I. So we're multiplying that 3 times. That's what it means when you raise the power to the third power. It means multiply this, whatever is in the brackets, 3 times by itself. So let's try to take the first 2 brackets. 2 times 2 is a 4. That 2 again multiplied by the negative I will be a minus 2i. Negative I by positive 2 is going to be a minus 2i as well. And then negative I by negative I will be I squared, positive I squared. So that's for the first brackets, right? Multiplied by the remaining brackets 2 multiplied by I. So before you actually proceed and multiply, always it's recommended you simplify. So this is going to give us something like 4 minus 4i. I squared, I did explain it's equal to negative 1. So that's what you have. And then you have 2 minus I. So don't mind the way I'm writing because you don't have enough space on the bottom. So at this point, 4 minus 1 is a 3. So 3 minus 4i, 2 minus I. Can multiply again. So start with a 3. 3 times 2 is 6. 3 times negative I is a minus 3i. We'll now go to the minus 4i times 2, that's minus 8i. And then times the negative I, that would be a positive 4. I is multiplying twice, it's I squared. And so this simplifies to 6. 3i minus negative 3 minus 8 is minus 11i. And then plus 4i squared, which is going to be 4 times negative 1, because I squared, I did emphasize, is equal to negative 1. And so we have 6 minus a 4, which gives us a 2 minus 11i. So we have 2 minus 11i. So you've seen, each time you have something dividing, before you think of doing anything with other given parts, take it individually, divide it by multiplying by the conjugate, and then also simplify this part and then bring them together to be easy. So 1 plus, we just collect like terms when you're adding and subtracting. So 1 plus 2 will just be a 3i minus 11i would just be a minus 10i. So we've expressed it in the form of a plus bi, where a and b are real numbers. This is our a, that is our b. Okay, so you want it to be in the form of a plus bi explicitly, so you can say 3 plus negative 10, right, I. That's still sufficient, right? Okay, so very simple and straightforward question. Now look at b. Given that sets a is equal to negative 6, 4, b is equal to that, and c is equal to that, and that the universal set is having numbers from negative 10 to 7, find the following sets and display them on the number line. Okay, so I've been doing sets for quite some time now, so this is not going to be a struggle. So I just give you a tip. Feel free to pause the video and try this one out. Okay, so I've answered it in the next video, so check out the next video. In this series you'll be able to check out the solution, of course, after you've tried it out.